Imagine walking into your favorite fast food spot, the smell of sizzling meat and crispy shells filling the air, and grabbing a taco that costs less than $2. Simple, right? But behind that bite of seasoned beef and crunchy shell lies a billion-dollar industry, high-tech food processing, and a story you probably never imagined. Fast food isn't just about convenience anymore. It's an industrial revolution unfolding in your kitchen, a carefully engineered system designed to feed millions every single day. Did you know that over 40 million Americans eat fast food every day? That's more than the entire population of California, twice over. And Taco Bell alone sells nearly 2 billion tacos each year, according to reports from Taco Bell and QSR magazine in 2023. But do you really know what's inside that taco? Or how much of it is actually beef? Buckle up, because this is going to change the way you look at your favorite late-night snack forever. When you bite into a Taco Bell taco, you probably think you're eating 100% ground beef seasoned with spices. But back in 2011, Taco Bell faced a major controversy after NPR reported they were sued because their meat filling allegedly contained only 35% real beef. The rest? Fillers, seasonings, and ingredients you might not expect. While Taco Bell fought back and denied those claims, insisting their recipe was 88% USDA-inspected beef and the remaining 12% was seasonings, oats, and water for texture, the case left a lingering question: what really goes into that taco? And how did a traditional Mexican street food, once handmade and bursting with authentic flavors, turn into a mass-produced product designed to last months in storage and still taste fresh when reheated in under 30 seconds? To answer that, we need to travel back to the 18th century in Mexico, where tacos began as a humble miner's meal. Picture this: workers wrapping spicy meat inside soft corn tortillas for a quick bite during breaks. The word taco itself originally referred to an explosive charge wrapped in paper used to break rock in mines, small, powerful, and easy to carry. Fast forward to the mid-20th century, when Glenn Bell, a California entrepreneur, saw the growing popularity of Mexican food among Americans. He didn't invent the taco, he saw it, studied it, and re-engineered it for mass consumption. Instead of fresh, soft tortillas made daily, Bell introduced the pre-made crispy taco shell, something that could be packaged, stored for months, and served in under half a minute. And that innovation didn't just change Taco Bell, it changed fast food forever. The story of how those shells are made is as fascinating as the taste. It all starts with massive sacks of dried corn, each weighing about 50 kilograms, delivered to industrial processing plants like Teasdale Foods. These aren't your small kitchen setups. Workers use forklifts to dump these sacks into stainless steel vats where the corn undergoes nixtamalization, a traditional process turned industrial. Water and calcium hydroxide, also known as lime, are added to break down the hulls and unlock the corn's full flavor and nutrients. This mixture is boiled until the kernels soften, then cooled and rinsed several times to remove the loosened skins. What's left is pure corn goodness, ready to be ground into masa, the dough that forms the base of every taco shell. Unlike wheat dough, masa is thick, slightly elastic, and carries a distinct aroma of cooked corn. From here, machines take over. The dough is rolled out to precise thickness, 1.2 millimeters, and cut into perfect circles. These discs move down a conveyor belt into an oven blazing at 200 degrees Celsius for about 40 seconds. After baking, they're cooled rapidly to lock in structure, then stacked in piles of 12 or more. Interestingly, at this stage they're still flat. That famous U-shape doesn't happen here. It only happens at Taco Bell stores during final assembly when the shells are heated and folded. The genius behind this design is efficiency. Keeping them flat saves space, reduces breakage during shipping, and speeds up assembly in the restaurant. But what about the meat? This is where things get even more industrial. Taco Bell sources its seasoned beef from massive meat processing facilities in the American Midwest, the heart of the nation's beef supply chain. These plants can produce nearly 500,000 kilograms of meat filling every single week. Inside, the process is divided into zones. Cattle arrive, are stunned, and slaughtered using automated systems. Carcasses move to cutting zones where high-speed saws and conveyor belts trim away bones and fat. The remaining meat goes through grinding, mixing, and seasoning stages. The recipe isn't a mystery anymore. Ground beef, water, oat flour, isolated soy protein, maltodextrin for texture, and a blend of onion, garlic powder, and proprietary spices. The mixture is partially cooked, cooled, and vacuum-sealed in 2.2 kilograms bags, each bag enough to fill 50 tacos. These are shipped frozen to stores, where they're reheated in steam ovens in under 30 minutes. If you think that's the end of the story, think again. Every ingredient in your taco, from lettuce to cheese to that spicy sauce, has already been through its own processing plant before it reaches the store. Lettuce comes from industrial suppliers like Taylor Farms, where it's washed in sanitizing solutions, chilled and prepackaged in sealed bags. Tomatoes are machine-diced and vacuum-sealed. Cheddar cheese is shredded and coated in a thin layer of starch to prevent clumping and extend shelf life. Even the sauces, whether it's fire, mild, or hot, are manufactured at specialized liquid food plants like Ken's Foods or Ventura Foods. Massive grinders pulverize chili peppers into a paste, which is then blended with tomato concentrate, vinegar and thickeners inside stainless steel tanks before being sterilized and packaged. By the time all these ingredients reach Taco Bell, nothing is left to chance. Every item is pre-portioned, pre-cooked, and ready for lightning-fast assembly. A taco takes less than 20 seconds to build. One heated shell, 43 grams of beef, a handful of lettuce, a sprinkle of tomatoes, some shredded cheddar, and a pump of sauce. That's it. In one day, a single Taco Bell location can serve over 2,000 tacos, especially during peak hours. Multiply that by the thousands of Taco Bell outlets across the U.S., and you begin to understand how fast food became an unstoppable force in American dining. Now, let's talk about another deep-fried classic that crossed the Atlantic and found a home in American pubs and diners: fish and chips. It seems simple, a crispy golden fish fillet served with a heap of fries. But behind that meal is a global supply chain that spans oceans and continents. Fish and chips started in the 19th century as cheap street food in the UK. Cod or haddock fried in cast-iron pans, served with hand-cut potatoes wrapped in newspaper. Fast forward to today, and most of the cod in your fish and chips doesn't come from Britain at all. Over 90% is imported from Norway, Iceland, or Russia. These fish are caught in icy North Atlantic waters by industrial trawlers, cleaned on board, and packed in ice before being shipped to processing plants in places like Lithuania or Poland, where labor costs are lower. In these plants, fish are skinned, deboned, and cut into uniform fillets with machine precision, then flash frozen at -40 degrees Celsius to preserve quality. These frozen fillets travel thousands of miles to distribution hubs in the UK, US, and beyond before reaching your plate. And what about the chips? Those golden fries are rarely hand-cut anymore. They come from giants like McCain or Lamb Weston, where potatoes are peeled, sliced, blanched, pre-fried, and frozen for up to 9 months. When your order hits the fryer at a restaurant, it's actually the second time those fries have been cooked. This double frying method ensures the perfect crispy texture every time. What ties tacos and fish and chips together is the industrial precision behind something that feels casual and familiar. Every step, from the factory floor to your plate, is designed for speed, consistency, and cost efficiency. That crunchy taco shell, that steaming fish fillet, they're the result of global supply chains, billion-dollar processing plants, and advanced food engineering. Next time you take a bite, remember, it's not just food, it's a system. A system built to make you crave, come back, and never question what happens behind the scenes. Have you ever wondered what really happens behind the scenes when you order your favorite comfort foods like fish and chips, a warm slice of apple pie, or that gooey mozzarella cheese on your pizza? Most of us imagine something homemade, maybe a cozy kitchen, a grandma rolling dough, or a chef hand battering fish. But the reality is far different. Today, these classic dishes are mass-produced using cutting-edge technology and highly engineered processes that guarantee the same taste every single time. From deep fryers and automated slicing machines to stretching vats and blast freezers, modern food production is a fascinating mix of science, precision, and speed. And trust me, after you see how your favorite foods are made, you'll never look at them the same way again. Let's start with something crispy and golden: fish and chips. A classic comfort food that traces its roots back to England but has now become a global favorite. When you bite into that crunchy piece of battered fish, what you're really tasting is a carefully engineered process. It begins with frozen fish fillets, often sourced from large commercial fisheries in the North Atlantic or Pacific. These fillets aren't just dipped in any batter. They are coated in a pre-mixed formula packed with pH-stabilized ingredients designed to maintain crispiness even after a long delivery ride. This special batter ensures the coating clings perfectly to the fish, creating that golden crunch we all love. Once coated, each piece of fish is plunged into hot oil heated to a sizzling 180 to 190 degrees Celsius. That's roughly 356 to 374 degrees Fahrenheit, the perfect range for deep frying. Here, every second counts. The fish spends about 5 to 6 minutes in the fryer, just enough time to form a uniform crust without cracking or falling apart. The result is a crispy exterior and a moist, tender interior that stays flaky even after cooling slightly. But fries, oh the fries, are a whole other story. Those golden potato strips are given special treatment. First, they're blanched, then frozen, and finally double fried. This two-step frying method is the secret to creating fries that are crunchy on the outside yet fluffy and soft on the inside. It's this delicate balance that makes fish and chips such an addictive combo. The entire process, from freezer to finished plate, takes less than 10 minutes in most modern kitchens. But here's the twist: fish and chips are no longer just a dine-in experience. In today's delivery-driven world, these meals are packed in oil-resistant paper boxes that are not only leak-proof but also insulated to retain heat. Shops use special steam-proof warmers or heat lamps to keep those portions crispy for up to 30 minutes after frying, just enough time for your Uber Eats or DoorDash driver to reach your doorstep. Behind this seemingly simple dish is an intricate production and delivery system designed to keep your meal hot, crispy, and Instagram-worthy. Now, let's cross the Atlantic and talk about a dessert that has become a symbol of America itself: apple pie. It's the star of Thanksgiving dinners, the subject of patriotic slogans, and a dish that feels like home. The phrase, "as American as apple pie," didn't just happen by accident. But here's a little secret: apple pie didn't actually originate in America. Its earliest known recipe dates back to 14th century England, where it was made with apples, spices, and an unsweetened crust. When European immigrants brought it to the U.S. in the 18th century, it evolved into the sweet, cinnamon-spiced version we know today, thanks to the addition of sugar and local apple varieties. Fast forward to the modern era, and apple pie has become an industrial marvel. According to the American Pie Council, Americans consume over 180 million apple pies every single year, and most of these aren't homemade. They come from large-scale factories run by brands like Sara Lee, Marie Callender's, and even Costco. These pies don't start in a quaint kitchen with a grandmother rolling dough. Instead, they begin in sprawling processing plants where technology and precision rule. The apples used in these pies often come from Washington State, Chile, or even China, regions known for their massive apple production and stable supply chains. They're harvested in bulk using mechanical shakers that can clear entire orchards in a matter of hours. Once harvested, apples are washed in disinfected water, then peeled and sliced by high-speed machines. We're talking thousands of apples processed per hour, enough to make millions of pies each year. After slicing, the apples are treated with citric acid to prevent browning and calcium chloride to help retain their crunch during baking. Then they're frozen and packed into large bags, ready for shipping to pie assembly plants. But apples are just the beginning. The real magic is in the filling: a thick, glossy mixture of sugar, corn syrup, modified starch, and sometimes artificial flavors. This syrupy blend is cooked in massive vats at about 140 degrees Fahrenheit to achieve the perfect consistency. Cinnamon and nutmeg are often added for that classic flavor, though many factories now use synthetic extracts for consistency and cost control. Next comes the crust. Forget the image of someone kneading dough by hand. In reality, pie crust in industrial settings is made with a blend of flour, vegetable shortening, water, and texture-enhancing additives. The dough is chilled, rolled into thin sheets, and cut into precise shapes by automated machines. These sheets are placed into aluminum trays before the filling is added. A second sheet is then laid on top, and here's where a little artistry comes in. Instead of hand crimping the edges, factories use air pressure to create folds and vent holes, mimicking the look of a homemade pie. Finally, the pies go into giant industrial ovens where they bake under carefully controlled conditions to achieve that signature golden crust. But the process doesn't end there. After baking, the pies are rapidly chilled in blast freezers at -40 degrees Fahrenheit. This locks in flavor, preserves texture, and extends shelf life. Before freezing, some manufacturers even spray a light layer of caramel or vegetable oil on the crust so it browns perfectly when reheated. Once frozen, the pies are boxed, labeled with batch codes, and sent to cold storage where they can stay fresh for 6 to 9 months. The next time you pick up an apple pie at your local grocery store or grab one from Costco, remember that it's the product of an incredibly sophisticated system designed to make every bite taste exactly the same. And then there's mozzarella, the king of melting cheeses and the star of pizza night. Mozzarella wasn't always the mass-produced ingredient we know today. Originally, it was an artisanal cheese from southern Italy made by hand from water buffalo milk. It was soft, perishable, and meant to be eaten fresh within a few days. But today, mozzarella is a global commodity, produced by the ton in massive factories using cow's milk and modern machinery. So, what gives mozzarella its signature stretch? It all comes down to protein structure and pH. It starts at the dairy farm where fresh cow's milk is collected, chilled to 39 degrees Fahrenheit, and transported to the factory within hours. There, it's tested for fat content, protein levels, and acidity before undergoing pasteurization at 161 degrees Fahrenheit for 15 seconds to eliminate harmful bacteria. After pasteurization, the milk is poured into huge stainless steel vats where starter cultures are added to develop acidity. Once the pH reaches the perfect level, an enzyme called rennet is introduced to coagulate the milk, turning it into curds. These curds are cut into tiny pieces to separate them from the whey and then soaked in hot water at 175 degrees Fahrenheit. This heat treatment makes the curds pliable and ready for stretching. In giant stretching machines, the curds are kneaded and pulled until they develop that iconic elastic texture. This process realigns the protein fibers, creating the stretch and meltability we love. Once stretched, the mozzarella is shaped into balls, blocks, or shredded sheets. To stabilize the cheese and extend its shelf life, it's soaked in a brine solution, which adds flavor and prevents bacterial growth. Then, depending on the product type, it's either vacuum-sealed fresh or frozen for distribution. Fresh mozzarella has a shorter shelf life and is often sold in water-filled containers, while frozen mozzarella can last for months without losing its stretch. The next time you watch that gooey cheese pull on your pizza, remember, it took precise temperature control, advanced machinery, and food science to make it happen. What do fish and chips, apple pie, and mozzarella have in common? They're all foods that started as homemade favorites but have been transformed into industrial products designed for speed, consistency, and cost efficiency. Every bite you take is the result of a highly controlled process that ensures the same taste no matter where you buy it. And now that you know the secrets behind these comfort foods, do they taste any different? One thing's for sure, the next time you enjoy that golden fish fillet, warm slice of pie, or stretchy cheese, you'll appreciate just how much science and technology went into making your meal perfect.